Estimates of future climate change are essential for climate adaptation planning. In this module, we will cover projections of mean annual and seasonal temperature and precipitation using models based on a strong mitigation emission scenario, or RCP 4.5, and a business as usual emission scenario, RCP 8.5. The projections focus on anticipated outcomes for the 2050s. Much more detailed projections, such as projections of the probability of exceeding specific temperature or precipitation thresholds within a particular time frame, are now possible, but require an iterative process with individual communities to identify vulnerable sectors and infrastructure. First of all, we're going to look at projections of mean annual temperature for Beaver County in central Alberta. This plot shows model temperature for an area of 100 square kilometers, or a square that is 10 kilometers on each side, that is located in the center of Beaver County. The faint yellow lines are individual model runs based on the RCP 4.5 emissions pathway, and the thick yellow line is the median of those model runs. The model information is provided by the Pacific Climate Impacts Consortium, or PCIC, which is associated with the modeling group at the University of Victoria. The purple line is the observed time series of mean annual temperature for central Beaver County. Note that the observed record fits within the envelope of ensemble model runs. The mean annual temperature at this location during the 1961 to 1990 base period is 2.1 degrees Celsius, and the projected mean annual temperature during the 2050s is 5.2 degrees Celsius. The change in temperature by the 2050s is 3.1 degrees Celsius at this location, relative to the base period. Added to this plot are the model projections based on the business as usual, or RCP 8.5 scenario. In this case, the projected mean annual temperature by the 2050s is 5.8 degrees Celsius, or 3.7 degrees Celsius warmer than the 1961 to 1990 base period. This plot shows historical and projected mean winter temperature for the business as usual, or RCP 8.5 scenario, and the more optimistic strong mitigation emission scenario, or RCP 4.5. The anticipated changes relative to the base period in mean winter temperature are 3.8 and 4.7 degrees Celsius respectively for the strong mitigation and for the business as usual emission scenarios. We are now looking at the same plot, but this time showing projections of mean summer temperatures. The changes in mean summer temperature by the 2050s relative to the base period are 2.7 and 3.7 degrees respectively for the strong mitigation and for the business as usual emission scenarios. In terms of mean annual precipitation, the model projections for the 2050s are quite similar. The anticipated changes for the strong mitigation and the business as usual scenario are in the range of 7 to 12% above mean annual precipitation during the base period. Breaking this down seasonally, we see that projected mean winter precipitation, based on both emission scenarios, is expected to increase between 13 and 15% above precipitation during the base period. In contrast, mean summer precipitation based on both emission scenarios doesn't show much change. The projections are for slight decreases in mean summer precipitation between 1 and 3%. Now we'll use the 20th century history of mean annual temperature in Beaver County region to assess the magnitude of the projected changes in temperature by the 2050s. The histogram shows the distribution of mean annual temperature in Beaver County from 1915 to 1999. The mean annual temperature during the 20th century was 1.8 degrees Celsius, and there were a few cold years with mean annual temperature below 0 degrees, and a few with mean annual temperature above 4 degrees Celsius. A bell curve is fitted to the data, and it's a pretty good fit. In this case, we are measuring projections from the mean annual temperature of the 1961 to 1990 base period, which is 1.9 degrees Celsius. The RCP 4.5, or strong mitigation scenario, projected change in mean annual temperature in the 2050s for the region is plus 2.9 degrees Celsius. Now, a change of 2.9 degrees Celsius doesn't seem like a big change If you walk out your door in the summer and it's 25 degrees or 27.9 degrees, you'll hardly notice the difference. However, in terms of mean annual temperature for the region, this is a significant shift, with a 2.9 degrees Celsius increase in mean annual temperature. This is how far the bell curve shifts to the right. When compared with the distribution of 20th century climate in the region, a warming of 2.9 degrees Celsius means that the average year in the 2050s will be as warm as the warmest 2% of 20th century climate in terms of mean annual temperature. Given that many built-in natural systems are designed for or adapted to conditions under the 20th century temperature distribution, a temperature increase of this magnitude underscores the need for resilience planning. Note that by the 2050s, about half of the years will be warmer than the most extreme hot years of the 20th century in the region. The projected rates of change in mean annual temperature over the coming decades for the region should be large enough to cause concern. However, these projections are based on climate models, and we know that there are uncertainties associated with climate models. It turns out that there is a pretty good qualitative means for assessing whether or not these projections are plausible. We're looking here at the last 50 years of change in mean annual temperature in the region. From 1967 to 2016, mean annual temperature has been increasing at a rate of 3.4 degrees Celsius per century. The model projections of mean annual temperature indicate that mean annual temperature in the 2050s will be around 4.8 degrees Celsius. If we simply extrapolate the rate of warming that has been observed over the region over the last 50 years, mean annual temperature reaches 4.8 degrees Celsius, not in the 2050s, but in 2061, which is definitely within the ballpark. This is significant for a couple of reasons. Firstly, it demonstrates that the rates of projected warming are not far-fetched, but are instead very similar to the rates of warming that have already been experienced in the region over the last 50 years. And secondly, people often tend to think of global warming and climate change as something that will happen sometime in the distant future. Clearly, the rates of warming in the region that have been happening over the last 50 years are sufficient to result in 2050s climate with an average year that is similar to the hottest years of the 20th century climate. And this wraps up Module 6 of Climate Change in Alberta, Climate Projections for Beaver County.